My experience, which is very limited, I've definitely been to a lot of facilities, especially smaller ones. I know that y'all's expertise is really in managing some really big sites, but a lot of times with smaller systems and older, smaller systems, like that would be thermostatic control on the cooling tower. The wet bulb would change and the cooling tower doesn't really know anything about wet bulb. It just knows about sensible heat and some set point it's been given to control to thermostatically. And so you get vastly different performance. Approach is changing drastically and you're not compensating it in the control system. That's a real opportunity for optimization. Is that what I'm hearing?
Huge opportunity for optimization. We see massive potential there in every water-cooled system. We should differentiate between air-cooled and water-cooled. But where we do have cooling towers, we see on some of those smaller plants quite often, if the design conditions say condenser water leaving temperature or the chiller wants condenser water entering temperature at 29.5 degrees because this was the design condition, that will be the set point. And you're leaving a huge amount of opportunity for efficiency on the table by running that set point there year round. Because in some conditions where your wet bulb temperature is significantly lower, you could actually lower that temperature set point. So rather than a constant condenser water temperature set point, what a common rule of thumb is wet bulb plus 4 degrees, for example. But this is when we get into what we call trade-offs. That set point and condenser water temperature optimization is a really good example of this. That set point represents a trade-off between cooling tower fan energy and the chiller energy. And the reason there we'd want to use more energy in the fans is because ideally what's happening then as we reduce that condenser water entering temperature, we're then reducing what we call the lift across the chiller, which means the compressors, that difference between condenser water temperature and chilled water temperature is lowered, which means the pressure ratio inside of the chillers is lowered. Those compressors have to do less work to transfer that heat. And in an ideal world, in a well-optimized system, the drop in chiller energy resulting from that drop in temperature is higher than the increase in fan energy. So from an overall perspective, when you're looking at it at a systems level, your kilowatts per ton or coefficient of performance at a plant level, at a systems level is improving. So overall, you've got more efficiency. You really, when you're optimizing these systems, want to take a mindset that you're agnostic as to which piece of equipment is using more or less energy. That becomes irrelevant. The real question that you should be asking is, how can I make the system operate as efficiently as possible?